Alright, welcome back. Sorry about the cutoff from the last video. The bell rang and I got pulled into some meetings and stuff like that. So what I'm going to do is I'm just going to start fresh again from this part here. So let's take a look. We have a continuous function of f of x, and notice that here it's given as a table, and here are the points. So this is the first point, which is 0, 7. So I'm not going to mess up this time. Where is 0, 7? Okay, where is 0, 7? Just kidding, it's up here, right? So 1, 2, 3, 4, 5, 6, 7. Okay, so that's the first point. Where is this point? 1, 3. Okay. Oh, I'm sorry, I should have said, alright, so what are we trying to do for this question? The question is, let's look at letter A. It says, what is the least number of roots that f could have between 0 and 6? So the idea is, because we're still getting used to this, let's put the points and let's see what happens, okay? So we could definitely answer A by ourselves, and B and C, I'll help you. So letter A, let's put in the points. So this is 0, 7, this is 1, 3, this is, let's see, 2, negative 1 is here, 3, negative 4 is here, 4, 1 is here, 5, negative 2 is here, and 6, 1, 2, 3, 4, 5. Okay, so these are our points, okay? And notice that we don't know, all we know is that from here to here, there's a connection, right? We don't, like, the graph could look like this, the graph could look like that, or it could look like this. We don't know what it could look like. But the idea is we know that they're all connected. So then the question is, how many times, what is the least number of roots this must have? Notice that it has to hit at least once, twice, 3 times, 4 times. It has to hit at least 4 times for this one over here. Okay? Let me just pause the video and just double check something. Hold on. So that wasn't too bad. I mean, it could hit more, but we know at least it has to have at least 4. And what was that idea that we talked about in the previous video when it said how many... Oh, wait, hold on. Let me get something real quick. Yeah. For this one, you see here, remember that idea with the deep level thinking? How many times did the f of x value, how many times did it change from positive to negative, or negative to positive? Notice before it changed 3 times, and that's the least amount of times there was a root. And that was the same idea here. How many times does f of x change from positive to negative? Well, it changes once, twice, 3 times, 4 times. Notice that it goes from here, you see positive, then here changes positive, negative, then this is negative, okay, then negative, positive, positive, negative, negative, positive. So you see it changed 4 times, so then there has to be at least 4 roots, okay? Now, what's the idea for the next question? What is the least number of times that f of x equals 6 for x between 0 and 6? And the idea for this one, what does this mean, f of x equals 6? What does this mean, f of x equals negative 3? I want you to pause the video and figure that out. What does this mean? Okay, and we've done this plenty of times. For this one, this is just a horizontal line at y equals 6. And this is the same thing as y equals negative 3. So let's look at this one. If I have the line, this horizontal line of y equals 6. So let's see, where is it? 1, 2, 3, 4, 5, 6. Notice that if I draw this line here, how many times does this graph have to at least intersect, or how many times does this graph have to equal 6 as a y value? And then that will occur once. Let me write that down. Hold on. The y value, or the f of x value, equal to 6 for this graph. And notice that because we have one point that's here at 7, the graph goes down. So algebra, you see, visually it's 1. Okay? But the real question is algebraically, how many points? You see, we need to have a point that where f of x is greater than 6 and f of x is less than 6. You see, once you have a value, like if I have a value above 6 and a value below 6, then you will have at least one point where that y value is equal to 6. And that's the idea here. This is algebraically how to justify it. This is how you justify this algebraically. Okay? What I want you to do is try and algebraically and how do you visually and algebraically figure it out for this one? Okay? For f of x equals -3. Well, let's take a look. Let's have y equals -3. Let's use a different color. Let's use green over here. So for this, let's see, where is -3? So 1, 2, 3. And notice that I could do this, right? So visually, notice that it hits at least 2 times. There could be, you know, like 100 times where it goes up and down, but you know it has to at least hit twice over here. And what's the reason why? Because over here, notice that if I have a point over here, and let me do this and do this. Okay, notice that I have one point here and one point here. So this value over here, you see this f of x value is greater than -3, and this f of x value over here, this value over here, f of x is less than -3. So once you have this condition, then there has to be one intersection that shows that there's at least one place where f of x is equal to -3. Okay, so for this one was 2. All right, I hope this was okay. This wasn't too bad. We will get together as a class tomorrow and review all this. Okay, I'll see you.